Let's have a closer look at methods and classes. So, overloading methods. Once in a class, there are uh, say two or more number of methods who are having a same name, but the number of parameters are different. We used to call this overloading. So these methods are said to be overloaded, and the process is refers to as method overloading. The type and the number of arguments as its guides to determine which version of the overloaded method to be actually called. Uh, Another thing is the return type is not sufficient enough to distinguish two method. Return type may be it may be different, but it might not be overloaded always. So the determining factor is number of type and the number of arguments. This is the determining factors that which version of the method you are going to call. Now, in this example, you can see there is a method called test. So void test, there is no parameter. Void test int a, there is a single parameter, integer type. A is a parameter I'm passing. There is void tests int a and int b. So there are two parameters, two integer parameters. Now here double test double a. So return type is different. It's not void, it's double. And also the parameter is a double parameter. So it's returning a into a. So whatever the value you are passing, that a into a, it is returning, and it is a double value. But in these three cases, it's only print statement. So there is no return as such, it's void. Now here, if you create an object OB and double result, then ob.test, ob.test10, ob.test1020, result equal to ob.test 123.25. So now if you print this result, it will print it will show you the output. Now here in the first case ob.test, it's only taking it's a no parameter case. So here if it is passing through the 10, first case is no parameters. Second case, if you pass 10, so it's only one integer you are passing, so it's a 10. If you are writing ob.test 1020, so you are passing two integer value. So this particular method will be called, this version will be called, so test int, and it will show output 1020. If you pass ob.test 123.25, that means you're passing one double, the return is also double. So this particular version of the method, test method, will be called, and it will show output 123.25. So here this is the result. In results it actually shows. Now coming to this one, automatic type conversion. uh, Same things, same function. The method is here also test. Second method test int, third one test double. The return is void. I'm not returning anything. So three three parameters. One is no parameter, one is two parameter, one is double. Now if we write int I equal to 88, and if you create an object ob, now ob.test no parameter, ob.test 1020, it will call this particular version 1020. ob.test I for in our case it is 88. So 88 means it will try to find out where the number of parameters, a single number of parameters are there. So it will automatically call this particular version. So that is a double A. So this will invoke test double that particular version. So it will show 88 display. And last one, ob test 123.2. So this will also invoke test double. So the output will be 123.2. dot 2. So even if its I is integer value, int I equal to 88, but still it will automatically convert, the type conversion will be happen, and it will automatically convert into double A. So this is called automatic type conversion applied to the overloading mechanism. Now method overloading supports polymorphism. Polymorphism means one interface multiple methods. There are some languages which doesn't support any kind of overloading. So for each method we need to give unique names. Uh, you will want to implement essentially same method for different types of data. That is one challenge. Like for example, absolute value function. There are some programming language who doesn't support overloading. So you need 2 to 3 or more than that version of the function, which is slightly difficult uh, for naming. Like in C, there is a function called ABS, absolute value, absolute of integer. Now for absolute of long, we used to write long integer, for we used to write LABS. For say floating numbers value, absolute value, we used to write FABS. So every time it's I mean it's to find out the absolute value, but depending upon it's an integer or float or long, the name of the method getting different. So the methods, this is because C doesn't support overloading, but in Java the method will be the same, only single method. There will be no separate second name. It should be ABS only, and that method only the parameter passing parameters will be different, or the return will be different. So here I see actually this makes things more complicated and complex for the computation. But Java, as it supports overloading, so these things, handling this kind of situation is much more easier. So here you can see there is a box constructor. This is a class box class having width, height, and depth. This constructor actually all those values specified, double W, double H, double D, initialized with D, W, H. This is I mean what one type of default constructor. Here constructor I am assigning all one value. So this is another version. Here three I mean parameters we are passing. Here no parameters. Here we are passing only one another parameter, double length, and all equal to length. So it's a double length. And last one is a method which is double volume. So you're computing the volume of the box. Now here I'm creating three objects, my box 1, my box 2, and my cube. My box 1, I'm passing three values, 10, 20, 15. So it will go to this particular version of the constructor, and it will compute. Here I initialize for this one, no parameter passing, so it will go here. So initialize the value, and here there is a single value 7, so it will go somewhere here, and it will find out I mean the constructor will take value from here. This is double length, so all these values are same, so it should be a cube, so it's my cube. So now you find out the volume, my box 1 dot volume, my box 2 dot volume, or my cube dot volume, and these all three will gives different volumes. Now we can pass object as parameter. Here in this example, like test, there is a class AB2 integer value. Now in this test, int I, int j, we are assigning to A and B. I and j we are assigning to A and B. Now there is a method we are calling, that is called the equals. So Boolean equals, we are passing this object test O. So of this particular class, we are passing one object test O. Now if O dot A, that is the passing first parameter, equal to A, and O dot B equal to B, then returns true, otherwise false. Now here we have created three objects, OB1, OB2, OB3, and test I am passing 100 and 22. So I equal to 100 and 22 is J. So A and B are 100 and 22. The second case, object 2, OB2, A and B 122. So in both these cases, O1 and OB2, A and B and A, this both values are same. But OB3, A and B value is -1, -1. They are different from OB1 and OB2 values. Now if I call these equal methods, OB1 dot equals OB2. So if I want to check that the passing value, if I pass this object test O, so I'm created OB2 as an object, I'm passing through this equals method, and OB1 dot equals OB2, it will check OB1 and OB2 and it will show that no, these two values are exactly same, so it will return true. But here OB1 dot equals OB3, OB3 is not equal to OB2 or OB1, so the return will be false. So here the interesting part is we are passing this test O is an object. We are passing an object inside this equals method, which returns a Boolean value. So this is the program where we are using, we are passing objects as parameter. Now, in this example, you can see this box allow one object to initialize another, one object to initialize another. What is that? Like box OB. So I'm passing one object as a through inside the constructor. So just to initialize another. Like here, this box height with depth, I'm passing this object here OB dot width, OB dot height, OB dot depth, all these I'm assigning height, width and width. And then box double W, double H, double D, this all I am assigned the value. Box without parameters, I'm setting -1, and box double len, I'm equal to all equal to len. Now there is a method called volume, it will compute the volume. Now if I write my box 1, my box 2, and my box 3, here 10, 20, 15, so it will go somewhere here, this particular version. There is no parameter, so it will go here. There is one parameter, so it will go here. Now my clone equal to new box my box 1. So what I'm saying, I'm passing my box 1 object, this object through the box, and it will create a copy of the box. It's called my clone. So I'm just replicating this my box 1 to another box, and that is my clone. So in this way, this clone dot volume, the volume of the clone dot volume and the my box 1 volume will be same. So here what we are doing, this box is allowing one object to initialize another. So to initialize this my clone, we are passing one whole object, and that object is my box 1, which is actually initialized by the constructor where the number of parameters are 3. So how to pass by value. So primitives types of passed by value. Here test, there is a method met and int I and int j. So int 2 equal to 2, int j divided equal to 2. Now as a call by value, so test ob equal to new test, there int a equal to 15, b equal to 20. Now ob dot met ab, I'm passing the value ab. So what will it will do, it will simply pass 15 and 20, and this 15 and 20 will pass as a value, and it will print that ab before call it was 1520, and ab after call it is also 1520. Now if as a reference, if I pass test int I int b, so a equal to I, b equal to j. Now void math test o, that means I'm passing as an object. So I'm creating an object of this class and passing that through this, and then o dot a into equal to 2 and o dot b divided equal to 2. So here what I'm doing, that is ob dot math, I'm passing the object ob. So whenever I'm passing the object ob, that means this ob is passing as an object, and then after that the value will be something like it will be multiplied by 2, and this value will be divided by 2. So initially it was 1520, so it will be 30 10. So here we are passing as a reference. We are not passing as a value. In the last case, it was passing by value.